Good evening, everybody. Welcome to those of you in the room and to those of you online as well. Oh, that's a very weird echo. Thank you for coming to the Geological Society Summer Public Lecture. We're doing something a little bit different today. So for those of you in the room, I hope you all have pads of paper and pens and pencils at the ready. Before we get started, I just want to do a couple of housekeeping bits and pieces. So as you will have heard before one of our events, we're hopefully not anticipating any kind of fire drill this evening. So if the alarms sound, please do treat it as a real situation. We've got fire exits at the front of the lecture theatre here and at the back under the green sign, and there are a number of Geological Society staff in the room. So please feel free to follow us out into the courtyard, and we congregate just outside the Royal Astronomical Society's door in the main courtyard. Hopefully we won't be disrupted, because it is my absolute pleasure to introduce Matthew Partridge today, who is here from Errant Science. So today's public lecture is on how to cartoon geology, which is something a little bit different for us in our public lecture series, but something that we hope that you'll appreciate. For those of you that are joining remotely, welcome as well. And throughout this lecture, your microphone and your cameras will be off, so we won't be able to see and hear you, but we'll make sure to keep an eye on the chat and to open those up again at the end for questions at the end of today's session. So geology is a huge subject, and it encompasses countless disciplines as diverse as paleogeography all the way through to astrogeography and cosmic chemistry. Even for the geologists amongst us, it can be daunting to look at some of the subjects that are outside of our own comfort zones and those that we know really, really well. And like any science, It's always better when we communicate that and it can be understood by diverse audiences, not just those that are scientifically trained to understand those subjects, but those that might be inspired to consider reading up about those subjects to learn a bit more in their own time. Any outreach that we can do to the wider public is beneficial to us as scientists who have a social responsibility to communicate why our science is important, particularly here in the UK, where a lot of research is funded by taxpayers. That has never been truer than it is today. And that is where things such as cartoons can come in. Now, that may seem like an unlikely solution to communicate the complexities of geology, but through simple drawings, some humor and personification, cartoons can make this an ideal tool. So without any further ado, I'm going to hand over to Matthew, who's going to take you through to how to cartoon geology. Thank you very much.
This is a great start. The clicker doesn't work. I'll see if we can go forward. There we go. Okay, I might have to do manual clicking through the booth today. So hello, welcome to How to Cartoon Geology. My name is Matthew Partridge, as thankfully very nicely introduced. And I'm here to talk to you today all about how to cartoon geology. I'm going to go through that in a few kind of steps. So I wanted to kind of like lead you through what I'm going to be covering. So I'm going to start with a little introduction to who I am, what cartoons are, because that isn't as simple as you might think, why cartoons are important, particularly important to geology and to science, and how to draw your own cartoons we'll get to at the end. That part has a draw along section, which you're welcome to take part in, but you don't have to, and it won't be a big part of the talk, but I wanted to try and encourage you to do something along those lines. So first off, a little bit about me. I have a bachelor's in biochemistry. I then went and got a PhD in molecular fiber optic sensors, and I've developed sensors for blood biomarkers, hydrogen and nuclear reactors, soil moisture, all kinds of different things. And I now work, so that's all the serious stuff, and now I work as a full-time cartoonist science communicator, and I'm the founder of Errant Science, which is very much not a serious thing at all. Very, very unserious, because at Errant Science, we love rocks and we love cartoons. Now, Errant Science started as a blog to share science. I wanted to try and communicate what being a scientist was about. And I started doing that in about 2012. I very quickly realized that if I just write stuff on the internet, that's really boring. No one likes it. So we added some cartoons in around 2013, and then it got a little bit more traction. By a little bit more, I mean more than my mum read it. The cartoons were, it's fair to say, awful. They were little things that I drew in paint, but they were little cartoons and they illustrated articles. They got slightly better as time went on, emphasis on the word slightly. And then I carried on doing that for about 9 years. And the cartoons now, again, have got slightly better and more colourful, and involve more geology and more science and other things. And now Errant Science does not just the cartoons and the blog, but we do video animations, we've done outreach projects, all sorts of ways of helping scientists communicate. And that's what we do, and that's why I'm standing in front of you, to explain cartoons and explain that kind of outreach. So to start off with, what is a cartoon? Now, as I said, you'd think this would be an easy thing to say, but there are many definitions of the word cartoon, and we're going to quickly whistle through them, starting with the oldest definition, which is that a cartoon is a sketch or sort of a pre-drawing of a larger piece of work. So for hundreds of years, that's what a cartoon meant. So Leonardo da Vinci prepared cartoons, Michelangelo prepared cartoons. They are hanging right now in the National Portrait Gallery, should you wish to wander down the road and go see some of them. But that definition doesn't really describe what we're here to talk about today. What we're here to talk about today is the definition that came about in around about 1843 with Punch. And Punch's magazine and the cartoons that they produced within it. And this is the first named cartoon. And this was produced as a satire on the Houses of Parliament. So this is kind of like it's like a meta joke, which is how it ended up being called cartoons from here on out. But on the walls are cartoons that were being shown in the Houses of Parliament as examples of things that could be painted on the walls for the learned people to look at while they debated the bills of the day. And these are the poor children who are not fed, looking in confusion at these cartoons, wondering how on earth these are going to help them. So it was, as you will see shortly, cartoons tended to be, which is at this time very satirical in nature. But you can see it's quite a simple drawing with a very simple point that it's trying to get across. But this coined the term cartoons. The actual the act of drawing what is that kind of simple line drawing goes back obviously far further than the name. This is dated 17,000 years ago and is on a wall in France. And this is a series of very simplistic drawings of animals and animals in action that were painted by early humans. Interestingly, not only are these kind of simplistic in a way and could be described as cartoons, they also are possibly the first evidence of the third description of cartoons, which is an animated piece. So some research was done by Mark Azima, who showed that they believe that these were actually kind of primitive versions of animation. Within each one of these drawings was multiple cartoon-like drawings, where if you stack them, it looks almost like frames of an animation of, in this case, an animal running, which is better illustrated by this little tiny GIF. The first time a cartoon, an animated cartoon, was called an animated cartoon was obviously not in the 17,000 years ago, but it was actually in 1908. And this is just, the completeness of history, the first ever animated cartoon called Phantasmagory, and is made using hand-drawn animations. But we are here not to talk about animated, we're talking about just the hand-drawn, simple, one panel often images. And those that were being created around the 1700s and 1800s, those were very, very much focused on simple drawings relatively. This is quite complex really, but simple compared to some of the more detailed paintings. But things that were telling a message or telling us a particular story, often satirical is where it started. And as you can see, this is by William Hogarth, and this is a satirical story all about the difference between people who drink beer and people who drink gin. It seems at the time people were not fond of people who drank gin and believed that they would be throwing babies away and debauching themselves in the street, whereas the people who drank beer were very civilized and very polite. I like both gin and beer. I'm not sure where I fit on this scale. But this was one of the earlier kind of that use of satirical kind of line drawings. A much more famous one and the British Library considers the most famous of cartoons or famous of drawings is The Plum Pudding in Danger, which was around about 1805, and it's all about carving up the world by the powers that be of Napoleon and Pitt the Younger. But these were satires of politics. Science was obviously not, in any way immune to these things, and that was also satirized in these early kind of cartoons where you had satire. This is an anti-vax cartoon, where implying that if you have a vaccination, you will end up with pigs coming out of you, or cows coming out of you, I should say. And it's that kind of, again, it's trying to, as terrible as the message is, as a cartoon, it's sort of showing that interpretation of injecting someone and then them having a cow coming out of them in that kind of simplistic cartoonish style. Not just the anti-vax messages, you also get quite a lot of misogyny around that time. We're not through with that now, but this is an example of the female philosopher, who in this case is actually Caroline Herschel, smelling a comet. Because she couldn't possibly have come up with a very clever way of viewing comets and understanding the sphere around us. She must have come up with some stupid way of smelling the farts coming out of a comet, and that was what this cartoonist thought was so funny. And it's from not just generic science. Geology has a huge history in cartoons and about the way that cartoons tell those stories in geology. And one of the best examples that I kind of have to start with, it's not particularly chronological, but I have to start with, is Delabecq, who is a former president of the Geological Society. And he had very interesting attitude to debate, which included drawing caricatures of the people he was disagreeing with and getting these published in various magazines or occasionally pinning them up in the street. And in this one, he is lampooning his opponents as part of the Devonian controversy. If you don't know what that is, Google it and read the Wikipedia entry after this, because it will take me the rest of this session to explain what that is, I think. But you can see here, he's being pretty rude about most people, including himself. He has given himself an impressively large nose. He clearly thought that was his very defining feature that people would recognize him by. Delebecq also liked to kind of mock people's opinions about what they were doing in geology. So this is another cartoon he drew a little while later called Awful Changes. And in this, his point was that it's quite a relatively complicated cartoon, but this is Professor Ichthyosaur giving a short lecture to the surrounding animals about the human skull. And this was him lampooning some of his fellow geologists who didn't believe in evolution. And they believed that species would just appear and then they would disappear kind of naturally, and there would be no change. And he was kind of arguing that eventually an ichthyosaur, a Professor Ichthyosaur, may appear, by which time the humans will have disappeared. And like that was what he loved, communicating his ideas through that. He enjoyed the humor of it. And I think, to be honest, reading about him, he enjoyed the reaction that it got from the people that he drew. But in moving away from more reactionary stuff, it was used as a sort of an artistic tool to explain sort of things that were changing in geology or ideas that were coming about. This is quite a nice drawing about sort of a geologist dreaming of the sort of the way that fossils would be put together. This is quite it's got a Shakespearean quote at the bottom that's been slightly changed to art thou but the mammoth of my dreams. And the interesting thing about this was that the mammoth's tusks are the wrong way round, because at the time this was drawn, that was the prevailing thought, was that the tusks kind of curved backwards until fossil records moved on from that. Geology still popped up from time to time in magazines being satirized. So this is a sort of a satirical protest about the geologist James Scott Bowerbank. He had a house which he set up to be like a geology museum, and he let people come in for free and look down his microscopes and look at his geological samples. And so the obvious reaction to somebody doing that would be to mock them in national newspapers. Because, you know, why else would you do something so nice? The Geology Society has some brilliant other examples of this. Is the Geology Familiarly Illustrated. The actual book is a serious book of geology illustrations, but the cover is trying to poke fun at the idea that these fossils are related and linked, and, you know, you should read this and understand it. And it's kind of an example of the humor of cartoons being used to grab people's attention and make people think about what they're now about to read about. And just to bring it kind of almost full circle, the Geology Society also has been featured in Punch, although a little more recently in 1928. If anybody could explain this joke to me, I'd really appreciate that afterwards. This is beyond my knowledge of geology, or Punch is humor of the 1920s. And more recently, things that the Geology Society have done historically are still being drawn by cartoonists and satirized. So Kate Beaton is a brilliant cartoonist, and she drew this cartoon to remind us all that at one time Mary Anning, one of the great geologists, was not thought of very favorably by the Geological Society. Things have moved on, and I'd like to point your attention to the Geological Society has a load of fact sheets all about how amazing Mary Anning is now, and times are slowly changing, I hope. But I don't think, you know, taking you through all those examples, which I hope you found kind of quite interesting, I really want to make sure that everybody understands what a cartoon is, what makes a cartoon for the purposes of the rest of this talk. So this is an example of a cartoon, a geoscience cartoon that I drew. And this was something I drew in 2018 at EGU. And it's about a paper that someone was presenting about volcanology meets geoheritage. And this paper was intended to explore how indigenous populations get on with their volcanoes. What they think about their volcanoes when the volcanoes have stopped being exciting and when they need to settle and they need to populate the areas or grow crops and do other things. And all I wanted this cartoon to do was give people a bit of a flag that's kind of the context of what this should be about. And it's a very simply drawn cartoon. It's not illustrated to 500 layers with beautiful art and coloring. It's just got little stick figures that don't even have faces. It's interpretive. You can kind of see that that's a volcano, but that is by no means the diagram of a volcano. But I think most people here would say that is a volcano. It's got an exaggerated art style. Those people, that volcano, not to scale, not required in when you're doing something that's like interpretive and simple like this. And I would argue that it's humorous. That is very much up to the opinion of the reader. But that person has a cute little flower, and I thought that was funny. And that's kind of, this is what a cartoon is. They are simple drawings. They're often interpretive. They often have an exaggerated art style. They are occasionally humorous or satirical. We have moved somewhat on from satirical. They are now far more humorous than they are satirical. They've moved out of punch and into the wider world. But that's kind of the crux of what the DNA of what a cartoon is. Which is a great place to say, why should we use cartoons, or why should we be interested in cartoons when it comes to geology and to science? And that's the thing that I kind of care about very deeply, because that's the kind of the part where I want to convince people to use them themselves or to draw them themselves. And as a scientist, I know how most science starts. Most science starts out its journey once you're doing the experiment as something looking a little bit like this, varying from subject to subject, with notes and data being turned into figures. And some of those notes are thoroughly incomprehensible only to the person who made them, and those figures are also occasionally incomprehensible except for the person who made them. If we're lucky, people might go that step further and make diagrams, and they might be about as comprehensible as this, which I did ask very kindly for permission for. And yes, eventually, I suspect you could go through and understand all of this. But in terms of getting an immediate sort of idea of something, that is quite complicated, as is this, which again is quite a nicely laid out diagram. But it's, boy, that's going to take a lot of text to explain, I think. Likewise, this one, which is a pretty hefty amount of overlapping little colored circles. I really hope no one is colorblind, or this is going to be an even more of a pain to see. Or you get really complicated diagrams. This is from a real paper, but it was interactive, which is quite nice. This shows modern publishing methods. Or there are some diagrams that are so complicated, it seems like some people will never understand them. But we hope that one day somebody might begin to understand these things. And when we have those diagrams or those data or those graphs, we then take those and scientists put those into places. We've got several different options, but generally speaking, it starts with papers. Well done, anyone here who has a paper. They're lots of hard work, and I'm not trying to denigrate the fact that papers do have to exist and they are very important. But as a first gateway, that can be tricky, not least because there are 2.9 million of them produced every year. Which is an astonishing amount of science and social science and other humanities. And it adds to a total of around 50 million papers that we now have to kind of weed through and understand. But it's okay if your science or your diagram didn't end up in a paper, one of the 2.9 million. Maybe it was very important and it ended up in an article or ended up on a website. That's great. That's another place that we can kind of get that information. But it's hard sometimes to then communicate that in the right way, depending on where you put it. And again, those diagrams aren't necessarily going to be helped by having a shorter, simpler explanation. You could, of course, put them out on social media, which I like to think of as the DIY approach to science communication. But again, you're putting out all those diagrams and all those figures with it's no longer 140 characters, around 240 characters. If it's X, this cartoon needs updating because it's no longer a little blue bird. Or if it's on TikTok, it's a 30-second video or whatever you want to try and share it with. And so all that complexity of that data and those diagrams and all those different ways that you want to try and share those things is where cartoons come in. That's the problem they're trying to solve, is that existing network of communications, that existing pile of complexity and data. And the first way they do that is that you want them to be simple. So cartoons are that. They're meant to be simple and they're meant to be nice, easy to understand drawings or things that kind of immediately jump out at you and you go, yeah, okay, I kind of get what that is. And I'll get to more complex examples of where you are simplifying a complex idea. But to start with, it could just be something like this, where you're just saying, hey, here's a stone that I find interesting. This is a thing that is interesting. And you don't need to go a lot more complicated than that sometimes to just get across that one little idea. It's not about explaining your entire research project. It's not about explaining, the complexities of how you came to this exact thing or the data sets that were required, because all of that will hopefully be in papers and in your other data sets or in scientists' other data sets. Cartoons are hopefully there for the public to get that first idea. And it can just be something as simple as comparing one little thing to another thing. So what about draw something nice and simple like a stone, and then draw a stone that is slightly blue to explain that you study bluestone. This is geologically accurate. I had this checked. And that's a great start. That's enough to be an explanatory cartoon that just explains one simple little idea. And that's a great sort of communication tool. But where you can go even further with cartoons is, yes, you can draw stuff simply. We'll get to that later when you're doing it yourself. But it's trying to make sure the audience partly understand it, but also connect with what you're saying, and will remember it and will want to go and delve deeper and look at that research or look at those papers or understand that area even better. And when you want them to do things like that, that's where you come to personify and personification. And cartoons are very, very useful for being able to do that, making you emotionally care about something, even when the thing you're emotionally caring about is a stone or a rock. So I could give you an example of just how easy it is to kind of do this in cartoon, because personifying sounds a long word and it sounds complicated, and particularly, it can be hard to understand why or how easy it could be to do it. And so to help me with this demonstration, I have this lovely pencil. So this pencil I've named Brian. Brian is the pencil that I took out of the cupboard this morning, and I drew some cartoons on the train with Brian. He's a really good pencil. I don't know if Brian will get up to much after this, because unfortunately, Brian is dead. But by going, collectively as an audience, you have brilliantly proven my point. All I did was I named a pencil Brian, and I gave him like 2 sentences worth of backstory. And a majority of you had connected emotionally to that lovely little pencil. And that's quite something. I've just made you care about a pencil enough to go, like, imagine what we could do with some data that we're really into and we actually have a deep story about. And it's so easy to do that personification. It really is as easy as naming it, or as the Geological Society has been doing of late, putting eyes on little stones. So this is my little stone called Emma. I've had Emma for actually a really long time, since the Geological Society first made these. Back in 2019. You can often get your own little Emma and take Emma with you and take photos of Emma, all about doing geological things. I've seen them still on Instagram and at events. And just having a rock with eyes on it that people take places into the wide world and into rock formations and down to the Jurassic coast and all these things helps people kind of think, oh, I've got a reason to kind of like go do this thing, or this is my little rock called Emma. And it really works. And it doesn't just work with rocks, and it doesn't just work with pencils. It works with all kinds of different things. So these are a lovely collection of rocks that a friend of mine lovingly covered in eyes for me. This is a very surprised looking humidity gas generator that I used to have in my lab. This is Sean the sheep, that someone very nicely put together. I think it is really impossible to see a wine box anymore. But it's that thing of like, it just makes you suddenly think of that as a Shaun the sheep. And that's, you care about that wine box far more than you would have done if it didn't have eyes, because it's been personified. And so what are some other examples of this? Some examples of where we're doing more things than just a rock, or more things than just a box of wine. So these are some examples both from things that we've done and other cartoonists have put together, where it shows you some examples of that simple and that personification to try and connect people and link people to the work. So here's one that we were commissioned to do earlier this year by, I believe now, Dr. Kirch. And this is explaining some of her research into the way ice compacts and reforms at different pressures and depths, which she was studying. By removing ice cores and then looking at them under a microscope. And what she wanted to convey in this is she just wanted a simple cartoon that really just said what she was looking at, which is, this is what ice is at different depths. And she wanted a cartoon that showed that at the upper depth, at the upper levels, the ice was in these big, stable chunks. And it was happy. Look at those happy faces. And then somewhere in the middle, she wanted to show that it was under compaction and it was under stresses in a way that were forming discontinuities, and the ice wasn't happy anymore. Look at those very sad faces. And then further down, the ice has then refound a new stable point of smaller ice crystals. Again, look at the now much smaller happy faces. And that she just wanted that to make her work feel like a little bit closer to her. Other research groups were looking at wanting to do cartoons that explained their work in hydrology. In this case, well, they've done personification just by adding a little bit of text and adding a little, there's some little people up there discussing things. But it's the same sort of simple drawings. That is not a detailed diagram of what they do and how they drill for water, but that explains very clearly the sort of what the arguments are for their investigations. And actually they've done so many more cartoons like this, where they use them to illustrate a whole bunch of different parts of their processes. I particularly like the divining rod one, where it's saying you should check the bit that already has water. That is exactly how they work. But they're trying to get across various points about thinking carefully about what aquifers are and where they are, rather than just giving up because there's only a small puddle or various other things. Because that's their whole thing. And I do encourage anybody who wants to see more of those or even use those to go to their website, because they have a really lovely selection. You also have a cartoon like this, which again is sort of a simple but quite beautiful art style, where it's just explaining the sort of the way those animals change as they grow up. And it's, I think, far prettier than I can draw. I stick to stick figures, as you may have noticed. But you get a real sense of what's going to happen to those animals, and adding in that little bit to the dragon and that little kind of Ra and the other one complaining. Again, it creates that little bit of human-esque interaction between those two little common 5-line stinks, which is going to make you more likely to remember this as a sort of a lovely illustration. There's also the brilliant Tom Gould, who you can see in The New Scientist and about 50 other magazines. And he does really, really good illustrations, tearing apart all kinds of bits of science. I particularly enjoy this more sort of geology themed one. I mean, especially because this doesn't have personification. It just really has, in a way, just simplistic line drawings. You could argue the personification is in the delicious dessert. Only humans and people care about desserts. But it gives people who might not even have thought about what those diagrams mean a sense of what they mean. And I think this does a really good job of, if you aren't aware of how layered diagrams work and you aren't aware how sediments work and things like that, it gives you an in, it gives you something to think about. It's like, well, I know how deserts work. So, okay, I could maybe go look at this and I might then be able to understand how that works. Another really kind of beautiful illustration is this one, which is a lot more diagrammatic. It is trying to get across in a lot of information, but in a really nice, simplistic way that makes you want to put this on your wall and print this out and kind of, yeah, this is a really pretty thing I want to look at and understand. And again, it has that personification with the people at the top and what appears to be a rabbit with antlers. Not sure that's necessarily scientifically accurate, but I think the rest is pretty good. Again, but it doesn't have to be, this is beautiful, but it doesn't have to be this beautiful. Cartoons can really range from things like this to things that are a lot more simple and easier to draw sometimes. So this is actually what I've taken from a paper, where it is a cartoon of a kind, but it's a diagrammatic cartoon. It's a simple line drawing, simplifying the discussion that they're having about the way that the rocks collapse. It doesn't necessarily have the personification, but it does have that simplistic style, and it's easy to look at and go, yep, I get this. I kind of get how that works. And it's not quite got to the point where it's a deep, detailed diagram. It's something a lot easier. But going back to stuff that's much more obviously a cartoon, you've got things like this that we did, where this was a researcher who wanted a cartoon because they study crystals that are either broken or have formed wrong for some reason. And they use computer analysis to understand them. And they actually did a presentation which was about how they want more people to understand that this is important research, and that understanding bad crystals is as important as understanding good crystals. And that was what they wanted us to get across in their little cartoon. And they wanted this to put online so that people would come and ask them, why do you care about cracked crystals? And I hope that is what we put across. And I hope, that's how they're using it. You get sort of bigger cartoons that are sort of more informative. So I'd like to think this is a slide in any geology practical, but where it's just trying to inform people about some of the things around volcanoes, and maybe this is hanging up somewhere near an Icelandic volcano or another active one somewhere. But this is sort of, when you talk about cartoons that anyone can draw, this isn't drawn so much as it is blobs of color. If you note the sort of the lava is just kind of like squarish blobs of one color, and the land is different spots of dark. Unlike this, which is beautifully hand illustrated, I suspect, over several months. And this is all explaining how boilers and steam engines work. I bring this one up particularly because this is a very good example of kind of more graphic novel style cartoons, where there's actually an entire book that goes with this at that website, which explains a huge amount about trains and a huge amount about the thermodynamics going on within trains. But they don't always have to be about that. They don't always have to be that detailed, and they can be those sort of simple things too. And they can also, which is where we started, be about life in the subject. And so these are by a cartoonist called Stephen Harris. This one's a little blurry, but it's about what it's like to be a geologist, what it's like to be a volcanologist. And sometimes those are stories that also need telling, and maybe those diagrams aren't so easy to draw. We did one ourselves a long time ago called the Geology Badger, which we just wanted something that was kind of funny and would make people think about geologists in the field. For this talk, we updated this because this is from 2017. So I have cutified it and made it far more internet friendly. So this is the new improved Geology Badger to try and explain. And I talked about, that creating these cartoons as a way of kind of sharing with people these ideas in geology. And I also wanted to show where that has also happened. So this is where different cartoons are being used on social media. People are tweeting their research by using the cartoons as a flag. So in the case of the two on the right, they're both, here's a cartoon abstract of the paper. Go read my paper. Go understand my work. In the case of this is an article that we did a cartoon for this month, which is all about the way bubbles form on hydrogen probes, on hydrogen generators. And they wanted a cartoon that, again, would just kind of capture people's imagination a little bit and be a little bit interesting about, wait, what's this about? Why, can we come and read this? Because this is quite a deep article about bubble dynamics and bubble formation. You get posters which have beautiful cartoons in. So one of these is from the Royal Society of Chemistry next door, which is, they've done an entire graphic novel. And the other one is from EGU some years ago, where somebody has cartoonified their entire poster, which is super impressive. By the end of this, I don't expect anybody to be doing that, but if you ever get to that, please send us that, because they're beautiful. You even get cartoons appearing in papers. So these are two examples of cartoons that are used as part of a study into dementia care. I should say I'm slightly cheating, because while these were used in academic papers, this is from an academic paper all about why you should use cartoons. Very, very much cheating, but you should also look at this paper and read this paper, because it's fantastic. So how do you cartoon? The whole point of the lecture. That's the important last bit we're now going to cover. So this is a very much optional draw along section. If you don't do it, don't do it. Don't worry. Well, like I said, it's not going to be too long, but anybody can do this. It doesn't matter how bad you are at drawing, you can definitely do this. And we can start proving that to you, I hope, by asking you, if you were to take part, to draw a circle. Give everybody a second. Right, you should all be done. It's only a circle. Now, if you've drawn your circle, you should give yourself a rating out of 5 for how good your circle is. So here are some circles on a scale. I'd like to say that if you've done 5, you've definitely drawn a square. There is no argument about it. You are bad at drawing. We can't help you, but hopefully not many of you have drawn a square. Well done if you've done better than that. Have to, sorry, clicky thing's not working here. Give it a shake. No, we're stuck on this slide forever. Oh, there we go. Okay, we're getting there. Okay. So if you've drawn number 1, well done. You've drawn a perfect circle. Again, you're possibly in the wrong place. You are a better artist than me. Well done. If you've drawn something to number 2, you've also drawn a circle. That's a bit more my level. Number 3, it's still a circle. This is definitely discernible circle. If you've drawn number 4, it is a circle. Now, it might not be a circle. To make it a circle, as a cartoon, it's really easy. You tell people it's a circle. Cartoons, no one's asking you for the Mona Lisa. People kind of get it if you just tell people that's the thing you're drawing. So if you're drawing a complex scientific thing and you're a bit sure, I'm not sure I have drawn that kind of really complicated piece of science equipment, just write the name under it. People will get the rest. These are interpretive. Sometimes that interpretation may need help. And so if you've drawn 4, maybe give it a hand. Next, try drawing a shape, different shape, any shape you like. Doesn't matter, go nuts, let your imagination run wild. Emma is here as a model, should you need her. Right, I've drawn magically this lovely shape. I did that with no hands. But it doesn't really matter what shape you've drawn for the next bit, because now you've drawn a shape, you should draw eyes on that shape. To help with this, here are some example eyes. You could pick any of those. You could draw your own. I don't mind. If you've got colored pens, you can, add color and things. Again, very, very impressed if you go that far. I've drawn some lovely circular eyes, so very simple eyes. Next, draw a mouth. Again, to help you with this, I've drawn some sort of good mouths for you. Pick any of those. They're all pretty easy. At least 2 of them were drawn by my 9-year-old at the time daughter. So yeah, I hope you can at least manage those. Obviously, as a professional cartoonist, I've gone for a more complicated mouth. I'm very safety conscious. And then if you would like to, try drawing some arms and legs. I'm not going to give you examples of those because for stick figures, they're just lines. So it would kind of not be a very good slide, but just imagine. So draw some arms and some legs. I've drawn just legs, making mine infinitely more horrifying. And now if you've completed that, congratulations, you've drawn a cartoon. Because that really is it. I'd love to say that cartooning is more complicated and this job has taken me years to perfect, but it really is just drawing eyes and a smiley face on most objects. You can see some further science-based examples here. This is a whole bunch of objects, science objects that we've drawn, or I've drawn, eyes and faces on to try and make them a little bit more personified. So all of these objects were suggested to us by some people that follow us. I can identify about half of them because I have forgotten them since I drew them about 6 months ago. And they're all just different examples of the way you can take quite complicated scientific objects and personify them. That slightly spirally one just near the bottom right, that is CERN. And that's trying to personify a Hadron Collider. So there's lots of things there just to give you an idea of, it just adds a little bit of personality. You don't have to draw things though. You can, look for things that you're, in photos or in things that where you've already got data or you've already got photos if you're a scientist and you want to add something, and you can draw some stuff on that. You can skip the hard part and just draw the faces. You don't even have to draw the shape. And that's another way of, helping people connect and understand to that picture, or at least flag that picture to come and ask you more questions, or to flag that data set to make you come and ask more questions about porosity, or about plates moving, or about why there's a very strange Godzilla that is slowly creeping over England. This was a cartoon we did for someone on Mastodon, and they were very happy to have their cartoon get a lot of more questions about why it was now angrier when you study the wind speed. So coming to the end of the talk, what can you do next? Well, you, whether you're a scientist or whether you're just interested in science, could draw your own cartoons. Doodle on things, doodle on some of the things you see online, doodle on some of the science images you see online, or some of the things you have, and see if you can find a way to personify them or add some kind of human connection and simplicity to them. Share other people's cartoons that you like, that you think, hey, that kind of does explain that really complicated thing that I understand, and I think somebody else would understand it. And use them to kind of flag to other people that this is a way of understanding things. And finally, encourage other people to look for that fun, that Professor Ichthyosaur, that fireball throwing Godzilla, or that hugging broken crystals, and try and get them to communicate that and that love and that enthusiasm. Because if we can get people more enthusiastic about science and about geology, more people will understand it, more people will study it, and that will be just a better world for all of us. And I hope that you have been convinced to do those things by my talk. I know it's a relatively short run through, quite a kind of a big complex idea of trying to communicate things in a simple way. But I'm very happy to stand here and take lots of questions and answer more, and hopefully we might have some from the chat as well. If you don't want to put your hand up, or if you don't want to ask them in the chat, feel free to communicate on any one of these many social medias. By the time I finish this talk, there's probably another 3 social medias that have been created that I've not added. But please do reach out, and I thank you very much for taking part, and please share your cartoons online if you've got them.
I'm going to check. Yeah, all good. So we've got 2 questions actually today. One is from Waste Wizard Doodles on the YouTube chat. They've been cartooning waste for a while, and they've only had positive responses from people who have seen them. So they're kind of asking the question, the problem is getting exposure while also working in a full-time job. Can you offer us any advice on that, Matthew?
Well, you see all these social medias. I mean, the best way to get exposure for cartoons you've drawn about, things that you want to share or you want people to understand, is to put them up on places that people will see them, and put them up on things like those social medias. And one important trick is to remember most of those social medias have various forms of amnesia, and don't forget that you've posted stuff. So if you've got something that you think explains something really well, or you think you've seen someone else explain really well, keep posting it, put it up several times, because different people will see it, and hopefully it will get wider and to a wider audience. So.
And then we've got 2 other questions relating to font that have come through Zoom, and then we can hand over to you guys. The first one is, did you create your own font, or did you use one that's already in existence out there?
Cool, that is the very technical question about my presentation. I created my own font, which is very easy to do. You just download a little thing and you draw your own little letters. But my handwriting is generally terrible, so it took me a long time.
Second question was, what are the best fonts for cartoons, and do all the caps thing make the text less readable in general?
Oh, wow. Okay. Oh, God, they're getting even more technical. There is no perfect font for cartoons. There are cartoonists who do stuff in illegible scrawl. There are cartoonists who do stuff in Comic Sans, and there's cartoonists who use Times New Roman. You make the style work for whatever you like. If you like it, other people will see that and feel that, is my best suggestion. I do the capitals because I find it quite readable, and I think my capitals look nice. My joined up handwriting looks horrible, as again I mentioned. It's nice to have to admit that twice.
Fantastic. And any questions in the audience before we go? Oh, this one maybe. My colleague's coming over.
Thank you. Sorry, another technical question. Do you draw on paper and scan it in? Like how do you get it online?
Yes. So I should say, when I started drawing cartoons, that little thing wasn't necessarily the first. The first thing I did was I drew them on little post-it notes about yay big, and they looked awful. But I took photos and I kind of then made the background transparent, and then I kind of put them on a white background and then put those online. And that's how I started, was doing it by hand. And I moved from there to a very old clunky iPad mini, which again is like you're drawing a diagram like this big or drawing a cartoon like this big. And now I do it on a slightly bigger iPad and it works lovely, but you can certainly do it by taking photos with your phone and it still looks perfectly good.
One at the front and then.
Thank you. My problem is I want to get some very complex ideas, scientific ideas across. And if you can get a good cartoon, it really works. But I'm not very good at getting complex ideas across in a cartoon. Any advice?
So the advice is break your idea down into a story. If you can write like a little story about your idea, and then you take a look at what you've written as your story. So hopefully your story's got a little bit of an introduction and a little bit of a problem to solve and then a solution in some way. Maybe instead of thinking about one cartoon that tells that story, think about it in a couple of cartoons that sort of break it down a bit more easily into just 2 characters almost discussing that story to start with. And even if you just script that out, you might find that by setting the narrative out, it helps you realize where a good explanation of that complex idea might be. If you're to go back even a step further, is write out what your complex idea as though you're writing it to somebody who disagrees with you. It was a good place to start, because it makes you think and challenges the way you're trying to explain stuff. So I hope that does help. So.
Cheers. No, yeah, it was a really good presentation. So yeah, thanks for that. It was like, when you get a commission of a job, how many sort of like times do you go through it? Do you sometimes like send it to the client and they're like, don't like it, start again? Like, what's the sort of process?
It highly varies depending on the client and their deeply held opinions. In general, we tend to explain what we're going to draw before we draw it, and then send through a draft. Then we go through maybe like 3 or 4 little loops to make changes. The comments that we have had ones where we have thrown them away and started again, which is always a fun day. We've had ones where it's been very minor changes, like the one we did for Joanna. One of the changes she wanted was that I drawn a penguin, and she said there weren't any penguins where I worked. Change that for a polar bear. Obviously, that is vitally important to the ice parts, but it's part of the cartoon. And we had another one where it was about a group that do wastewater research, and I'd been a bit cautious and I had not drawn enough poop. And so I have an email that says, could you please add in more poop? Sure, we can do that. Oh,
What would you say is the most positive outcome that you think has come from communicating science in such an accessible way?
Personally, I think the most positive outcome was back when I started doing the blog and I was first drawing cartoons. I did a schools talk about the work I was doing at the time, which was a moisture sensor. And I thought, I like cartoons, I'm going to go all in. I illustrated the entire presentation. Every slide had a cartoon of some kind. And I went back to like a careers day at that school about 4 years later. And I was just on like helping out in the chemistry booth. And like a younger girl approached me with her older sister. And her older sister said, oh, wow, I remember you. You were here, you did a talk. I did physics because of you. Gotta say, made my entire job worth it. I'm just like, I've just been living off that for years now. But we've also, I mean, more practically, from a like when I was more in research, we had projects that were started because companies who worked in that area but didn't understand what we did saw a piece of a cartoon and went, oh, hang on, no, you work on what we want to work on. And they called us and we got a contract because we'd drawn something as a cartoon, or I drawn something as a cartoon. And that's that's a much more practical one. But it's the first one that I think about all the time. So. Just to reiterate, please do share your cartoons online through like the hashtaggy thing if you can. It's really fun to see what people draw. We don't always get rude ones, which is quite nice. Some of them are genuinely fascinating little bits of science, and I would really love to see them. So do share stuff.
On that note, let's thank Matthew again. Thank you very much. Okay, thanks very much, everybody. That concludes our lecture this evening. The details of the upcoming public lectures will be posted on our website. And just to reiterate, if you have drawn anything today, please share it with us with the hashtag Cartoon Geology and with Matt at Errant Science as well. And if you leave them behind, we may start sharing them on social media anonymously. So if you don't want your name on it, don't leave it behind. Otherwise, we'll find it. Thank you.